Okay, I'm going to show you how to solve problems using this. Many of you are probably thinking you could just read a problem, figure out what the variables are, and jam it in an equation. In acceleration, that becomes a big problem. So this is something you have to be very, very careful about. Here's why. Because things change directions. Acceleration could be in the opposite direction from the velocity. So I've got this approach that I use all the time that I think is useful. I call it the solve method. It's an acronym. S, sketch, O, objective, list variables, and equation. So for the sketch, I just mean frame of reference. That means pick a positive direction and a negative direction. Objective, what are you looking for? You're going to write something equals question mark. My pen's given out, so I'm switching over. Something equals, some variable equals question mark. You'll see why we do that. List the variables, okay, with their values. And then and only then, pick an equation. Choose an equation, okay? So I want to show you with those three equations, I want to show you with a sample problem. And the problem is this one. A ball rolls up a ramp. It starts at 2 meters per second. That's up the ramp. Acceleration is 1 meter per second squared down the ramp. Okay, well look, we've already got two different directions. That's going to cause a problem if you just start jamming numbers in an equation. Find the displacement after 6 seconds. Solve method. Sketch. Here's all you really need for the sketch. Ball's rolling up a ramp. I'm going to call up the ramp positive. That's my frame of reference, FOR, what I call. I just picked up the up as positive. You could have picked down as positive, okay? It will still work out as long as you are consistent, okay? So, sketch, the objective, the goal is displacement. Find the displacement. You'd be surprised how many times I see a problem solved for the wrong variable. List variables, sketch, objective, list variables. What do we know? Ball rolls up a ramp. Starts, V0 equals. Positive 2, up, is the positive direction. Positive 2. Acceleration is 1 meter per second squared down the ramp. Since all of these are all in happy physics units, I'm just going to leave the units out. But that's really important now. You can see that this is a different variable than if you just took 2 and 1 and 6. 2, this is -1. These are vectors. They have directions. I don't write this often, but I'm going to do it right just for this problem, just to show you. Vectors, you have to think about what direction, and you have to have defined a positive direction. And finally, time, which is a scalar, is 6 seconds. So now I can solve this problem. Notice, sketch, objective, list variables. The last step is equation. It doesn't mean solve the equation. It also means select the equation. We have V0, A, and T, and we're looking for delta X. Let's try this one. V0, A, delta X. Oh, we don't have V. V0, T, delta X, T, A. That's good. We have one unknown. So you want to pick the equation. That won't work. That won't work. You want to pick the equation that gives you one unknown. If it happens to be the unknown that you want, great. If it happens to be a different unknown, take note of that. You might want to use that equation. Sometimes we've got to solve one equation, use that unknown that's now a known in another equation. So basically it's kind of do what you can, solve what you can. So I said this was the equation. Delta X equals V0t plus 1/2 AT squared. And delta X, hey, I don't even have to rearrange this. The unknown's on the left. That's great. 2 times 6, I'm just substituting in, plus 1/2 times -1 times 6 squared. This ends up being 12. 36, 18 minus 18 equals -6. It's delta X. I need a unit, meters. Notice, if we had plugged in 1 instead of -1, we would have gotten 12 plus 18, you would have gotten 30. So in other words, this frame of reference doesn't just give you the right answer, the right number, it gives you the right answer, okay? You would have gotten 30, positive 30. That would mean that ball just be zooming up the ramp without a frame of reference, picking a positive direction, everything will fall apart. Okay? Okay, so then let's look at this problem. Oh, before we do that, I want to show you what that looks like on here. We had I want to see, you need to be able to graph these things too. So let's graph velocity in meters per second. And we know that it starts with a velocity of 2 in the positive direction. And it has a slope, and let's just do this, 1, 2, 3, 4, 5, 6. It has a slope of -1. So a slope of -1 would be like this, since the numbers are all 1. I made sure if you had the 2, 4, 6, 8, it wouldn't be 1 square to 1 square. Don't want you counting squares. Okay, so it would look like that. And we could find out the displacement like that. Okay, and it should come out to be -6 meters. I want to make sure you can go do these, solve these this way, solve these this way. Okay, we've got to think about them multiple ways. Okay, let's look at one more problem. And this is a nice one because there's only one number. Oh my gosh, people panic when they see this. Let's do that solve method. Sketch, throw a ball up. I'm going to do something different. Okay, that ball's going up and down, right? I'm going to call down positive, just because very few of you would intuitively do that. You could pick up as positive. I just want to show you that it doesn't matter. If I pick down as positive, it would work just as well. So there's my sketch. My objective is find displacement. List variables. I throw a ball up at 30 meters per second. That means it's leaving my hand. Its initial velocity is 30 up. Well, up is negative for me. It's the opposite direction of positive. Okay. Hey, I'm out of variables. I need 2 more. To solve any of these acceleration problems, I need to know 3 variables. Well, it's in the air. It is free fall. Free fall. So acceleration is 10 down. Down is positive, the way I defined it. And then finally, at the top tells me something. Remember, at the top is that special point where that velocity is 0. Okay? So we're looking for, I call them shadow variables. These are shadow variables. They don't give us those 2 numbers in here, but we know them just because we understand physics. So now I go through my equations. Delta x, v0, a, and v. v0, delta x, a, v. And that'll work for me. I can use that equation. So I have v squared equals v0 squared plus 2a delta x. V is 0. v0 is -30. Quantity, that whole thing, including the sign, squared, plus 2 times 10 times delta x. This ends up being 0 equals 900 plus 20 delta x. -900 equals 20 delta x. 45 meters, sorry, -45 meters is delta x. And again, so when we start doing 2-dimensional, I'll probably call that delta y since it's vertical, but you can definitely use delta x. -45 meters. What? It went up. How can I have negative? Oh, because up is negative the way I defined it. It's 45 meters up in the air. So that's how we solve that. And before I run away, let's do this. We had it leaving our hands at -20 meters per second. It's going to have a slope of +10, so let's do 1, 2, 3, 4, 5, 6. Okay, a slope of +10. Oh, I'm sorry, -30. Look at me, -30. So the rise is going to be 10 plus 10, because those are my units, velocity versus time, plus 10 over 1 second. Again, we deal with physical units. I really should write them, shouldn't I? Meters per second and seconds. So that tells me that after 3 seconds, because this has a slope of 10, rise of 30, run of 3, slope of 10.
And my delta x is going to be, remember, it's negative when it's below that graph, below the line. 1/2, base is 3, height is 30. The size of that is 30. That's 90 times 1/2. It's negative 45 meters. So that's a check on what we had there.